Hi everybody, this is Joe / FoozleCC, and today I'm going to be covering two topics. The first of which is on cellular automatons, which is a basic form of procedural generation that's kind of cool to see how it evolves and plays out. The second thing I'm going to be covering is my entry into Xanderjam number 3, which I used some of that in the game because the theme was evolution, and I thought it was kind of a cool concept to explore. So with that said, let's go ahead and dig in. Okay, everybody, so a cellular automaton, what is it? All right, let's look over here first and kind of ground ourselves. It's basically a grid of zeros and ones that we're going to visualize, and every so many ticks or however many seconds, it's going to evolve. And it's going to use a set of rules of, you know, how many neighbors it has, or maybe some other fancy rules you come up with, to determine the state of the next tick. And then it keeps doing that. And you don't have to do any input to this, or you could possibly allow the user to add input to it. But in our example, we're going to keep it super simple, and we're going to do the classic game of life example from John Conway from the 70s, where you kind of go in and it mimics, you know, reproduction and overpopulation and underpopulation based off some simple rules. And if you come down here, these are the three rules we're going to implement inside of construct 3 and visualize this. Any live cell with 2 or 3 live neighbors survives. So if I'm a cell and I look at my neighbors, aka the cells around me, how many neighbors do I have? So we're going to have to count how many neighbors we have. And if I have 2 or 3 live neighbors, I survive. Any dead cell that has 3 live neighbors becomes a live cell, aka I'm reproducing or something. And all other live cells die in the next generation, and similarly all other dead cells stay dead. Those are the 3 rules we're going to implement, and it will make something kind of interesting, you know, visualize on our screen. So with that said, let's jump into construct now and make this quickly. All right, so I'm going to go ahead and I'm going to do a, let's call this cellular automaton project tutorial. All right, 400 by 300 is what I'm going to do, so it's going to be a grid of 40 by 30 because I'm going to keep this, apparently I can't spell, oh, that's fine. Okay, let's go ahead and create it. And let's go ahead and redefine our layout to 400 by 300. And the first thing we're going to need is we're going to need a tile map. And I'm going to keep it really simple. I'm just going to have it be black and white, just like the example that we looked at. And to do that, I'm just going to resize this to 10 width, 20 height. Let's zoom in on here. I'm going to make this first cell a white cell, and that's going to represent our 0. And I'm going to make the second cell a black cell, and that's going to represent our 1. So let's go ahead and close this. Now we've got a tile map, 0 and 1. Let's change the size from 32 by 32 to 10 by 10. And if we zoom in here, we've got our 0 and we've got our 1. So we're cooking. We're already ready to go. The next thing we're going to need is an array. And this is going to help us keep track of our states, 0, 1, and then we're going to use that to also populate the tile map. Technically, you could do this all within the tile map, but for me, it's just simpler to think of it as an array and then populate it to it. So let's come over here and rename this grid. And I think those are the only objects we're going to need. So let's come into our event sheet. Let's do a system on start of layout, and let's also define some global variables. I'm going to need something that is going to define my grid size to do some of the math. And let's do, our grid size is 10. I'm also going to need some helpers. Let's call it rows and columns or calls. And I think I'll probably need a couple more that we're just going to use as temp call and temp row. So we've got these 5 globals, and I think that that's probably all we're going to need, but we'll jump into it and see what happens. So the first thing we're going to do on the start of our layout, let's define how many columns and rows that we have based off the grid size and the layout width. So system, set value, define the columns as layout width divided by, oh, let's do it as an int, just in case it's not even. Layout width divided by grid size. And that way, in case you don't have it nice, even division, it'll at least go to an int. And let's do the same thing for rows. All right, and except for this, for rows, instead of layout width, we're going to do layout height. All right, so now we've got our number of columns, our number of rows. And now we can use that to define our grid size. So let's come over here. Let's set our size to our width is columns, our height is rows. And I don't think this is necessary, but let's go ahead and clear it to 0. Okay, so we've got that going on. Now, we also have to have something ticking, and I don't want to just use the game tick. I think it'll look too fast. So let's come back here and put the behavior on our tile map of a timer. And once we've done that, we can come back here and we can kick that off. So tile map, start timer, and every half second, let's make it regular, let's evolve. All right, so now we've got this ticking timer that's going to evolve every half second. But before we get into that function, let's do some initial setup to seed our grid with zeros and ones, so it's not just all zeros. So let's do a couple of nested loops here. So add condition. Let's do a repeat, and let's do repeat on the rows first, and then similarly we're going to do that on the columns, nested. And as we do this, what we can do is we can set our temp row to our loop index, just to help us think about it and keep track of it. And let's do the same thing for the column. All right, so now we'll have loop temp row and temp column that we can use with each time we're inside of that nested loop going through. And when we're in here, now all we have to do is set our grid. So let's go ahead and do that. Set at, oh no, not X, let's set at XY. And for X, it should be our column, temp column. And for Y, it should be our temp row. And now rather than 0, let's do a floor of our int floor random 2. All right, and that'll give us a 0 or 1. Let's go ahead and give this a quick play and see if that worked. All right, if we go to grid and we go here, zeros and ones. All right, it's working, so that's good. Let's keep going. Okay, so now we've got our initial seed of zeros and ones, and we have to think about now every single time that we tick, we want to go through and evaluate a set of rules and decide what should my state be on the next tick. And then also we want to visualize it to the tile map, so we're not just looking at a grid of zeros and ones, and it will look a little bit more visually interesting. So with that said, the next item is to do a on timer with our tile map. Okay, so tile map, on timer, evolve. All right, we want to do a couple things, and let's think about this. Now, we have to loop through again, so let's just grab this because we kind of need to do the same thing. And we're also going to have to deal with a couple things, but let's set up some helper variables. Let's set up state, and let's also set up a variable that we're going to call neighbors. And let's talk about this. So we're going to do this thing where we're going to look at all the cells around our cell that we're investigating. And we're going to have to come up with a quick function to count how many neighbors we have. And we're also going to have to deal with some edge conditions, because if you are on like x equals 0 on the very left-hand edge and you try to go into your array to the left of that, you're going to get an error that you're out of bounds. So there's some ways we can deal with that. We can force the grid to be something that's on the edges, or you can think of it as like a sphere or something that's been wrapped, right? Kind of like our globe. So as you go out this way, it actually picks this one. And if you're on this edge and you go to the right, it actually picks this one. So we're going to create a couple of helper variables to do that. And let's call it wrap I, because we're wrapping, and wrap J. All right. And so we've got wrap I, we've got wrap J, and let's define those as we loop through. And let's do that inside of here and here. So instead of temp row, we're going to be defining our wrap I. And the simplest thing to do is to say that I'm my loop index, right? But like we said, that would become an error on your out of bounds. So we have to deal with this somehow, and there's a little trick that we can do. And what we're going to do is we're going to do calls. All right, so we're going to add the number of columns to our value. So if we've got 40 columns and I'm on 0, I'm going to add 40 to it. So now my new number is 40. But I'm then going to take that value and I'm going to do the modulus, the percentage sign, of calls. And this is a trick to let us wrap, because this gives us the remainder of this division. So this is now 40 divided by 40 is equal to 1, remainder 0. So this evaluates to 0. So it still works as 0, just like we put in loop index. But now if you were at the case where you are on the far end, it will, instead of going past, it will wrap you back around to 1 because it's giving you the remainder. That's why this works. So that's kind of an important step. Otherwise, you're going to get errors on your boundaries. And let's do the same down here and call it wrap J. Get rid of this. Except for instead of calls, we'll use rows. And we're good to go. Now, I'm doing this on rows and columns. Technically, I don't think it really matters because it can be like any number. But let's do this because I think this should be rows, just to keep it in the same column. All right, so calls and calls. All right, so we've got our I and we've got our J. And now what we need to do next is let's set our state. Let's go and figure out what our current state is. Remember, we've already seeded it at this point. So let's go ahead and set our value of our state equal to grid.at, and let's use wrap I, wrap J, and now we've got our state. Now we need to come up with a way to get our neighbor count before we do our rules, and then we're almost done. So let's do a separate function. Let's create a function. Let's call it count neighbors, and return type is going to be a number. Let's hit OK, and let's add a couple of parameters. Let's call it X, and let's add one more called Y. And from this count neighbors, we need to come up with a quick way to loop through the cells around it and count how many ones there are. So there's a couple of tricks we can do here. Inside of this, let's add a couple of local variables. Let's say sum is equal to 0, because that's what we're going to return, is the sum. Because what we're going to do is we're just going to add up all the cells because it's 0 or 1. So every time there's a 1, it'll tick up by 1, and that's how many neighbors we have. And let's add another local variable, and let's give it another helper. Let's give it a column and a 0 and a row. Local variable row. All right, and now I think we're good to go to do. We're going to do a loop around this cell. So let's call it for I is equal to -1 to 1. And let's do another nested loop underneath it. Let's call it J. Okay. And that is similarly also going to be from -1 to 1. Now, we have the same problem that we did before, where there's the potential that if you're on the edge, this will air out. So we need to use that same trick. So let's go ahead and set our call here to, do I want to do it here? You know what, let's just do it all down here. It doesn't really matter. It doesn't really matter. All right, set call to, let's go ahead and call this our, since we defined our loop index now, it doesn't really matter. This is just going to continue to repeat it. Loop index I plus x. Remember, so we're starting with x. We've been provided an initial input. So we need to do x plus the loop index of I. And the same trick that we have to do is we have to wrap this. And, oh, actually, let's also add on our columns. This is the trick. And let's divide by our columns. Oh, but instead of divide, it needs to be the modulus, percent. And I think that that is correct. I have a reference over here. Let me just remember if I did this correct. Yep, I did. Okay. And you know what? We can put this up here. It doesn't really matter. And then similarly, we can put this right here, but for row. And instead of I, it'll be J. And let's call this rows. And rows. And instead of X, it'll be Y. And now we can wrap and not have that issue, right? So that lets us deal with those edge conditions around the cells when we're checking it. Now, what's super simple now is what we just need to do is we need to say system set value of our sum. We're going to set it equal to the current sum plus the grid at, and it'll just be called row. So there we go. Now we've got the value of sum, and I could return it right now, but it's also going to loop through itself, and yourself isn't a neighbor. So what we need to do at the very end, after we've looped through all this, is subtract out myself. So if I happen to be a 1, subtract that back out. So you aren't you aren't counting yourself as a neighbor. So the way we can do that is just to call this again, and instead of adding this, we're going to subtract grid at and our xy, which is our position of ourself. I think that'll work. And then we can return it. So return value sum. All right, we got our helper function. Now we're counting our neighbors. So now we can use this in our evolve. That was necessary. So we come in here. We're setting our state, and we've got that. Now we need to count our neighbors. So let's do system set value neighbors is equal to function dot count neighbors, and we're going to pass in wrap I and wrap J. And now we'll get back our number of neighbors, and now we can set up our rules. And remember from Conway's Game of Life, we've got these 3 rules, right? So let's go ahead and set that up and see what that looks like. Okay. So the first set of rules we're going to do is we're going to use our state, because we just retrieved our state. So let's do compare two values is state equal to, so the first one we're going to do is if I'm dead and I have 3 neighbors, I'm going to come alive. That's kind of that first one, right? So if my state is 0 and my neighbors is equal to 3, then I want to take that and update the grid. Let's copy this over here, paste it in. I'm going to upgrade this from wrap I and wrap J. I'm going to update this to 1, right? Because I was dead, but I have 3 neighbors, so I'm going to evolve to have 1. All right, else. Let's come on in here, and let's do another couple of sub-events. If I'm dead, and oh, so this is the one we just did. So if I'm dead and I have 3 neighbors, I become alive. So now we need to do these 2. So let's come back here. All right, so now let's do system compare two values. If my count of my neighbors is, actually, let's first determine am I alive or am I dead. System compare two values, state if I'm alive. All right, let's see if I need to die. Okay, so if I'm alive, let's do another compare two values. Neighbors is equal to less than 2, or my neighbors is greater than 3. Let's make this an OR block. Then I need to set my value to 0. All right, so let's come in here, set that to 0. else. Now let's do the other one. So I think I need to do one more check. Otherwise, oh yeah. So if I'm alive, and I set that to 0 if it's less than 2 or greater than 2. Otherwise, I'm just going to keep my existing state. I don't even know if this is really necessary, but I think that's how I want to think about it. And then, otherwise, let's evaluate here an else, aka I'm dead. And if that's the case, I'm just going to set myself also to state, because I think that covers our rules. So if I'm dead and I have 3 neighbors, I become alive. If I'm alive and I have anything less than 2 or greater than 3, then I go to dead. Otherwise, I keep my same state. And similarly, if I'm dead and I have any other neighbor count other than 3, I stay dead. Let's give this a look and see what it looks like inside and whether or not this is working. Let's go to our grid. Aha! Look at that. Okay, 0 and 1s are flickering. That means it's working. Now let's visualize this so it looks a little bit cooler. And then we'll go on and wrap this up. So we've got our tile map here, and we're looping through. What we can do is simply, at the end of this nested loop here, is we can say, our tile map, let's go down here. Let's set the tile of wrap I and wrap J equal to my grid. Dot at wrap I and wrap J. And let's give this a play. Ah, the game of life. We did it. How long did that take me? I don't know. Not too bad. A little longer probably than I was hoping. But look, we did it. And this is kind of cool. And what you can do is if you have all these interesting initial states, you'll see these almost like organisms emerge, which is kind of an interesting thing. You'll see these pockets. And there's certain situations where you'll have these things called gliders that will move across the screen, and it can make for some interesting game mechanics. And so I took this in my game jam idea, and I decided to apply it towards generating these swarms of robots or drones that were guarding some things that you had to go and get. So now let's go into item 2, give my entry into the game jam a quick play. I'll also link that down below for you guys to play. If it is still able to be rated, feel free to give it a rate. Also, I did put the project file for the game in the link below. I will say it is quite messy as it was a jam and I didn't give myself a ton of time to go do it, but let's jump over and see what that looked like and how that turned out. All right, game of life. I'll also post this up also on that same itch page, just as a quick example of the game itch page if you want to download just this. Okay, so let's go now over to my entry. So I called it the Xanderwood Strain, and it is by Xanderwood. His link is down below to his channel. Great channel for Construct 3, and that's why I called it this, because it's his jam. And the gist of it is you're this like mecha that your engineer's sending you in to go and retrieve these vials. So let's go ahead and play it. All right. Let's go ahead, press enter. I have some pretty bad news. My research has concluded that the only way to end the pandemic ravaging our world is by sending you through this quantum portal to retrieve vials of dangerous Xanderwood strain we hid away years ago. Unfortunately, I went a bit overboard on safety. They are guarded by self-evolving swarms of drone using Cellular Automaton. You're the man for the job, so I hear. There are 5 vaults of increasing size. Once you grab the goods, aka the green vials we have to collect, I'll open a portal to the next vault, but if any drones are nearby the portal, will collapse and I will have to open a new one. So basically, we're going to go in, we're going to try to shoot down whatever drones we can, we're going to try to collect these green vials. Once we collect all of them, he opens a portal somewhere, but if you haven't cleared out enough of the drones, you won't be able to open the portal. So you have to, it's a mix. So let's go ahead and see how this thing turned out. I will warn you right away, if you try to play this and you have a lower end PC, you will struggle on getting through rounds 3, 4, and 5 because more and more objects are on each of those levels. I'll see how my PC does while doing the screen recording on round 4 and 5. I think I might struggle. But all right, so that was my little intro there. Now let's give it a play. All right, so we've got some AMO count up here. It's telling us, oh, there's one of our vials. Oh, okay. So you can see the cellular automaton going on, right? All right, and I see the other one. Oh, boom. Okay, so I already got 2. This is level 1, so that's good. Now we have to see where's my portal that's opening up. Ah, crap. Ah! Oh, there it is. But there's too many. You see, there was a drone nearby, so it collapsed. All right. Let's see if I can get lucky. Where's that portal? Alright, this is just level 1 though, so it's not too bad. Where's that portal? Oh, there it is. Okay, boom. Alright, level 1 complete. Let's go to level 2. Gets a little harder. Now we have to collect 4 vials. And there's probably going to be more baddies. Alright, let's keep going. Up in the bottom left of the map. Okay. Oh. These white guys are important. Alright. These are the big blasts. This really helps with clearing out the baddies. Alright. There we go. Oh, look at that. We've got 3 of them. Woo! Alright, let's keep going. Where's that portal? There it is. Ah. Come on. Alright. Let's see if I can find this guy. Oh, there he is. Alright. Level 2. Complete. Haven't died yet. That's good. Alright. Oh, I got an easy gimme here. Alright, I gotta get 6. Oh, look at this. Easy mode. Sometimes you get lucky, sometimes you don't. I already got 4. It's a good start. Got a good feeling. Alright, so one of the things I did like about how this game turned out is because of how I'm using this extra, like this layer here, of how I seeded the initial randomness. And I used some of the advanced random functions inside of Construct 3 to do this with some Perlin noise. You can see some of the world behind it, so you kind of get these clues as to where, you know, these things might be that we need. But you can't see everything. So you have to go and explore. And by exploring, you also spawn all these bad guys, right? So it's kind of this fun mix of having to explore, but you don't really want to explore because it spawns more of the bad dudes that you have to deal with. Alright, wow. Okay, I got a lot of stuff. I gotta clear these guys out. Nope. Alright. Let's come over here. I'm getting low on ammo. Oh no! That was a lot. Took a big hit. Oh, get lucky. Yes. Okay, here we go. Boom. Level 3 complete. This is really good. I normally have died at least once by now. It knows that I'm recording my video for my YouTube. All right, there we go. Oh, getting lucky. All right. All right. Let's keep these bad guys getting dealt. Keep them. If you get the quantity up too high, your game will certainly chug. And if you've got a low NPC, good luck. I apologize now. This game is not meant for you. I could have done some more to optimize my code on this, but it's a jam, so you only have so much time. Okay. Oh, look at this. I'm finding all of them now. Oh, crap. And you know what? You know, some comments are like, I don't like how they just spawn on top of you. I kind of like the surprise. You do get a little bit of time while it does the cellular automaton function on it, but then, yeah. It can be a little alarming when all of a sudden you see like 50 bad guys emerge on top of you. And you really don't know how big the swarm's going to be because it's doing that evolving function inside, right? Oh, where is this last one? Oh, crap. Wrong way. Okay. Where is everything? And you know, the trick of this game is you need to take out the big guys, and then they stop respawning. Otherwise, you're just letting them continue to respawn. Okay, the green guy must be over here, the final one. Oh, yeah, there it is. Oh no. Aha, okay. Boom. Did the portal open? No. Darn it. Alright, we're doing pretty good though. Haven't died yet, so that's pretty good. Oh, open up. There we go. Boom. Alright. I hope I clear this all in one try without dying. I feel pretty good. I don't think I've done that yet. Alright, final level. Like I said, I don't even know how my PC is going to do on this. I might chug a little bit with my screen recording software on it. Maybe though. Alright, we're definitely going to have some lag. I can already feel it. I'm already out of my weight, my big guys. Alright, there we go. That was lucky. Yep. I gotta get in there. Okay, I'm going in. This might be how I die. Alright, good. Just one more to go. And then I gotta get out. I'm getting lucky on finding these guys. Alright, come on. I need some more ammo. Holy crap, lag. Come on, get lucky, get lucky. Nope. Oh, come on. Where is it? Come on, be in here. Be in here. There it is. Alright, now we just have to find the portal. Game's over. Crap. Nope, can't go for that. Where is that thing? Alright, so we have to find this portal. Get lucky, and then we can get out of there. Good job. Come on, where is this thing? I thought about adding an indicator on where the portal is, but part of the challenge of this game is you kind of have to go and explore, and that's what causes the enemies to spawn. So I decided to... Alright, I think I've cleared most of the bad guys though, so that's pretty good. Alright, let's see if I can find it. There it is! Alright, I managed to beat my own game. That's good. But hey, that was pretty good actually. I normally die before I get to that point. So we collected all the strains, all the Xanderwood Strain vials, and we're going to use it somehow, I guess, to make medicine to combat the pandemic. I don't know. But that said, Cellular Automaton, I used that to make those swarms, and it was kind of a fun implementation of it, and I really enjoyed it. So anyways, with that said, everybody, I hope you enjoyed it. If you did, please consider subscribing, giving it a thumbs up, leave a comment down below. Really appreciate it. And also a quick shout out to myself. I am creating a new Discord server. Not many people have joined yet. I only have a couple people in there. But feel free to click on the link below to join, and we can discuss game dev and anything else really. But feel free to give it a join below, and we can, I can help you with Construct 3 and all those other good things. And that said, have a good day, everybody, and I'll catch you all soon.